still open. People will probably walk in. Hope everybody's able to hear me right now, otherwise my voice will probably reach the end of the room as well. Good morning, everybody. Welcome to NDC Manchester. We have kicked it off. First sessions next to each other. And in the next, let's say, 50 plus minutes, I'm going to talk to you about Beyond Trust and looking at .NET supply chain problems and see how we have the ability, or how we can find the ability to work together and to create a data set and create tools that everybody can use to have better grasp of their security problems. I think the biggest thing with security tools in general is the fact that it will give you fatigue if it produces too much, right? And I think every security vendor knows what I'm talking about. If you produce too much and if it's not actionable, it's not usable. So that's the thing. First, it's always polite to introduce yourself a bit. So my name is Niels Tanis. As you probably noticed, I'm from the Netherlands. I work as a security researcher at Veracode right now, and I've got a background in .NET development. I started out my development career with the first bits of .NET in the early 2000s. Seen it evolve, did a lot of contracting, but always kept my eye on software security in general. And in 2015, I joined Veracode, where right now I'm focusing mostly on our static capabilities on .NET, right? So .NET 10 has been released, and I'm getting my head around every piece of the SDK to see, like, hey, what's inside? What could possibly go wrong? What do we need to look into? It's quite cool. And I'm also enjoying a lot of Rust. I think Rust is a nice language if you want to learn something new. And I do a lot of these public speaking gigs, which I enjoy because I think my mantra always been like, okay, it's easy to break, hard to build. If we look at software security, everybody can probably show you that, hey, this is a SQL injection and how you can fix it. This is the way. If we look at prompt injections, the one we saw at the keynote, right, that's definitely the right take on it, right? It's a feature. It's not something you can deal with. You just need to accept that it's going to happen. But I'm a strong believer that we need to help out developers making better informed decisions. I'm still a developer myself. I love technology, but I want everybody to use them to the full extent and everybody to use them in a way that it's safe, or at least as safe as possible, right? And I've given talks quite a while, and over the last, I think, might be even 4 years. I'm not sure how long this cartoon has been around, but this is always the starting point, right? Everybody has seen XKCD ones, the SQL injection one. This is about, of course, dependencies in general, right? The stack of blocks, and what happens if one fails underneath, because even with open source and people maintaining it in their spare time, right? There might be something that occurs and we need to take action, but if one of those blocks fail, we have a problem, and we just assume it's just going to be there and we rely on it, right? That's a third-party risk thing. But this is a nice picture. Somebody a couple of weeks ago published this one, which it puts even more in it, right? We have a wrench that's called AI that will tilt it, and you're on the top, and we have Rust developers coming in and AWS outages. We see Cloudflare failing something. These are all things that end up in your system, which will make it a thing you need to think about, like, what are the risks I'm facing? But I find this one really amusing. I thought, like, I need to share this one and extend to the other. So what I'm looking into today is looking into certain, like, what are the challenges we see with general, more like NuGet package ecosystem. If you're pulling a library, what will happen? That kind of thing. And also how we can focus on securing our supply chain, right? And everybody has probably seen all the news with NPM over what happened over the last couple of weeks. Even I think less than a month ago, there was a similar thing with .NET. I'm not sure if you've seen it, but there's definitely a lot of movement in that area. I think we need to have a better understanding of the libraries we pull in, and I've been saying this, like, in all the talks that I talk about with third-party risk. We need to have better understanding of what the projects that we consume do for security and how it works internally, right? We grab something for a certain reason, because it's, hey, we're reusing, we're lazy, I'm lazy as well, right? You want to reuse stuff that's already there. But do you know exactly what the package contains and what it does internally, right? Because there might be something malicious in, as we're going to see in a bit. I want us to have a better way of reviewing packages. And I created some tools over the years, and I consolidate them into a single CLI tool. And I want to show you them. But I also am aware of the fact that I'm a security researcher. I want to see a lot of information and take decisions. But if you're developing, That's different, right? You don't want to have the noise and seeing all the other stuff. So that's the balance act I'm searching for, and hopefully you can help me out understanding what you would need and what you would expect of these kind of tools. And I can show you what I'm creating right now and going to share with you, and then hopefully we can get something going there. I also think it's worth being able to share feedback and being able to put stuff in. If I review something, I would love everybody to benefit of it, right? And if there's a way of sharing that information, I can show you that as well. It would help out. And then some ideas of what I want to do in the future. And then at the end, we're going to do some Q&A. Code cartoons, I've used them a lot as well. This is still one that I enjoy, because there's a lot of studies, there's probably different metrics, but if we look at software we write ourselves, it's mostly like 20% we write ourselves, 80% comes from other libraries. You can still question, do we use all of the 80%, or is it just marginal? That's another discussion, but I think this definitely shows, hey, there's a disbalance, and we pull in a lot of other things, and there's a little thing we write ourselves. If we then look at a report, and this is the only Veracode stuff you're going to see from me today. If you want to talk about Veracode, come see me afterwards. But we publish a report called State of Software Security, and this is the edition of last year. And if we look at all the apps that we've scanned, right, so we've got a SaaS-based solution. If you're familiar with us, we scan static analysis, different languages. We have statistics, and we figured out that almost 64% of the apps have a flaw in their first-party code, which is the code that developers create, that are there, right? But 70% of the apps have a flaw in the third-party code, right? So there's also a skew in that. And then you could still question, hey, is it in a library that I'm using? Is it something that's reachable, right? That's the other question. But it's definitely still a problem. I think it was a couple of editions ago, I think 4 years ago, we looked into open source. And one statistic we also saw is that almost 80%, 79% of the projects we have seen in that year of our data never update their dependencies. And that's quite worrisome, right? They've never touched it. So the project is created, it's used, and keep in mind that our data set is definitely active customer data that's being used at that point. And we saw that it was never updated, right? And what happens if we have a dependency tree? If you create a .NET application, you will have your tree of dependencies, right? So you'll pull in one package that helps you to do, let's say, retry mechanisms like poly, or you do PDF generation, that's the one I always use, or you're pulling in a library to do the log stuff for you. You pull one in, you'll get a whole bunch of it for free, dangling underneath, right? Maybe not even noticing it. And with .NET, it's inherent, if you have a process that starts your application, that bootstraps the fact that you're running this .NET application, the system access it has will be the same as the thing that started it out, right? In the old days, we had app domains with .NET first version that you can isolate and do code access security, which was a failure because it was really hard to do, right? But just assume that all libraries will have access to all systems, right? So that's the thing. So, and what happens over time? If libraries are used, and libraries are used a lot, then vulnerabilities are found, right? And that's exactly what we see here, right? So if somebody has the ability to hey, it has been found, and then I can influence it from the external side, then I can do some stuff and hack systems. What can we do about vulnerabilities? We have the .NET CLI, right? And this is a thing, if we look into the default one, this is a .NET application, a .NET 9 SDK. I'm adding a dependency, and I will check for vulnerabilities. I can do it with the CLI. This is cool. But it's all covered if we look into this, because I mentioned to you, if you pull in one dependency, you always get a tree of dependencies. So if we then say, hey, show me all the dependencies you rely on, you get this list, right? If you do the -- include transitive dependencies on your CLI. And if you then ask, are there any vulnerabilities, you will say yes. It didn't surface if you only look at the top level ones, right? It's underneath there, it's dangling, and there is some kind of Newton soft JSON dangling underneath this version that is vulnerable to something. So you cannot see this. Luckily, when I got the last bits of the .NET 10 SDK in November when it got released, this is the default behavior we see right now. This is the same app, but then compiled against .NET 10. It will give you the warning straight away. This is the thing I like most, right? It will show you instantly, hey, this is a transitive dependency somewhere, because there's also a thing called .NET Y. I was arguing, and you had to put a slide in. You can use .NET Y, search for that one. It can explain to you where a transitive dependency came from, where it originates from. So you can do something about this, right? This is cool. I like the fact that this is in the tool. I think they started out talking about this 10 years ago to get this in, right? And we've seen it grade into what it is right now. But having it produce warnings by default, that's a good thing. That helps everybody. If you're familiar with .NET, there's always .NET Conf during the release. And this year there was a real nice video done by Barry Dorrance. He runs the .NET security team, and he talks about 9 vulnerabilities that they found in .NET over the last year. And he will explain to you, like, hey, we had the 9.9 one that's really big, right? It's like a high risk. But he touches all of them, and I think this is good. I sincerely hope that what he did this year, like explaining all of this, is something that they will do on a repetitive scale. I'm not sure if Barry is fond of doing it, but I think this is nice. He talks about the process and also about the bug bounties behind it, right? People get motivated to help out fixing this, and everybody would benefit. So this is cool. So looking at the CVEs, right? So the one that we also saw during the keynote, the common vulnerabilities that are found in libraries, this is something you can get out of the box for free. Use it, right? That's cool. So what else can be? The situation, and this is the other one, that's a malicious assembly. It gone rogue, it put a mask on. Do we see this with .NET? And of course we see it, right? And I think this is an article that was published, I think, 2023. The letters are too small if I'm standing here. I think that's the one, March 2023. Targeting developers getting their crypto wallet contents. That's what this thing is doing, right? So if there's money to be made, then people probably will try it. I will try to push into it. And then does it stop here, right? Reversing Labs is a company that do a lot of cool stuff. I have two of their researchers in this presentation, but they looked into malicious NuGet packages based on homoglyphs, right? So based on the fact that an N can be represented in different ways. And somebody last week showed me that you can register something called entityframework.core, which totally looks like entityframework.core if you look at it, but then the N is a bit off. It is a different letter he used. And if you publish it, it will be taken down, so there is definitely something happening there, but it's hard, right? Can you imagine that if you have an LLM, code completion, taking that wrong name, or it is in the context somewhere, and it will just use it? That's hard. That's a hard problem, right? And also the fact that it uses IL weaving makes it a hard problem. We're going to touch this in a bit, because I think that is something we can do about, right? So that's like, there's a package, and I will weave additional IL instructions in the libraries. And of course, if we look at the public open source repo, there's always a source that it's been built on, right? And we need to match that. That's a problem we're going to cover in a bit. But this is like showing that, yeah, NuGet is definitely not free. I was doing breakfast this morning. Somebody says, like, yeah, NPM. I think technically every ecosystem has to deal with this. One of them a bit more than the others, right? But I think it's naive to think that NuGet is more like safe. That's not true. So this is what happened. This is a Socket blog post. This was happened a couple of weeks ago, where they figured out a campaign, which is like definitely a campaign, if you look into the details, about like 9 different NuGet packages that were compromised. And it turned out there was a single contributor by this name, which can be attributed to a certain country, I believe. That if you read through the details, you can figure it out yourself. But the thing that amazed me is that 99% of the library itself was functional. And what they did is they made in like a kind of error rate thing, like they wanted queries to fail X amount of the times. And they put that in the library. And they even had delayed logic that it had to execute in 2 years or 3 years, which, why would you do that, right? Why would you put that in? Maybe somebody is doing a contract right now and wants to have some guarantees of having a job at that point in time. Who knows, right? But why would you be that sophisticated? Why do you want to do that, right? And that's what's related to database queries. So and it was an extension method. So it was logic that you had to pull in, but once again, if we do some vibe stuff, I'm guilty as charged. If you do it, then it might be pulled in, if it's there, right? So it will be executed. And extension methods, extension fields, it's a new one, can allow you to tie stuff together. One other thing is that it also focused PLCs, and I think that's probably the value bit, right? So it had a library that is used to control PLCs, which is industrial controllers. And it had a thing that it would almost respond in such a way that there was a failure rate. So this is definitely something targeted, right? Why would you do that? Why would you spend that amount of time even producing all the other stuff? I still find this questionable. But this is good. It happens, right? And it surfaces there. So these are malicious packages. What else do we have which is more inherently tied to the ecosystem that we use if we look at .NET, right? And this is another blog post of Reversing Labs, but they talk about baggage that you get for free if you use a NuGet package. If we look at NuGet in general and we have a piece of functionality, then it might have a dependency with another NuGet package to do stuff, right? As I said, the whole transitive tree of things that gets in. There's also a thing called interop. You can do unmanaged DLLs, right? That's what we did in the early days with COM+, COM, all the things combined. Almost feels similar, right? What we're trying to achieve today. But you will have unmanaged DLLs inside your package, and that will then be called by the logic that you expose throughout the NuGet library. The biggest problem it has is that within the NuGet ecosystem, it's not identified as such, right? You need to look into the library to see, hey, it relies on DLLs inside that are not like source files I can correlate, but those are binaries that are being put in the repo. That's a flag. You need to check that because can you reproduce those? Do you know for sure what's inside? That's the question I will get in my head first time if I see that, right? But that's the thing, and there's like a lot of research done, like for SSH stuff. But there's also one that relied on zlib, and zlib is known to be only available in source. You need to compile your own version. So that library was using it, and it was tucked away, and it was vulnerable since 2005. So it's like 20 years of a vulnerability that you introduce because of that package, but it won't surface because it's a NuGet package. It's probably managed, right? If you don't look into the details. So know what's inside, right? And that's exactly that this slide captures what I just mentioned to you, right? Know what's inside. There are precompiled versions of DLLs inside. And keep in mind, like that set compression I talked about, medical devices, industrial things. Yeah, there's a pattern there, right? But it has severe vulnerabilities. And then one sidestep, if we look at know what's inside, I always find the example with XZ backdoor pretty significant on what happened there, because somebody put a backdoor inside of a lower bit of SSH that was used on Ubuntu systems. And the only way the guy figured this one out, he was a Postgres developer at Microsoft, and his timings of his tests were off. That was the only thing that got him triggered to look into this. So he saved a lot of people a lot of work. It probably introduced work because people need to patch, but still, can you imagine, right, what would happen if he wouldn't have not seen it? That's definitely a planted backdoor with a reason, right? I think this is definitely, we need to be more aware of what's inside and what we expect. And I will have an answer to that, like what can we do about that? So moving along and then looking into what can we do about our software supply chain? And I'm not going to touch that in a lot of more detail. There's a couple of talks given today. At 3, you need to be in this room if you want to know more about NuGet. I believe there's one later on in the afternoon as well about supply chain. But I briefly want to touch one framework that Microsoft produced, which is called the Supply Chain Consumption Framework. And you can find it. They contributed it back to OpenSSF. And it's a project there, and you can help out. But the thing that they do is they created a practice for you to work through to see like how can you help out securing your supply chain. And you don't need to fully understand like what's here, but just the 8 practices you see over there is like a clock. You will start at the top, and you could just iterate multiple times over it, and that will allow you to look into what you ingest, where it comes from, right? Let's say one of the examples that they gave. So the website and the paper behind this, you will have a lot of links, examples how to fix the problems that they were talking about. So look into that if you want to know more. But let's say ingestion. You're building a system that relies on a third-party library, and it's critical to your organization. Wouldn't it be a good idea to have your own local version that you build yourself to have control over the fact that you know what's inside? But also, let's say somebody takes out that dependency. It's not available anymore. What will happen then? We have seen it in the past as well. With NPM, sorry, I need to show that example, but NPM being tightly woven into each other, if you see those dependency graphs, small packages, if somebody takes one out, then the thing collapses, right? Would make sense. Know what's inside, right? Update vulnerabilities, and we can argue about if you want to update straight away, and I'm going to tell you in a bit as well. There's a lot of practices, and how can you deal with that? The thing that they also introduce is like levels of your program and how it can increase, right? So I think this is good. This will help you out securing your supply chain in an actionable way. And one of the pieces is also scanning and auditing, and that's the thing I want to talk a bit more about. Like, that's the thing I think can have more attention. And as I said, the other talks will continue to talk about NuGet systems in general and what you can do about this. A couple of weeks ago, somebody published this on dependency like problems, and even if you look at NPM right now, wouldn't it be an idea just to take a cool down and not update to the latest version? And there's definitely arguments to say no or arguments to say yes. I think this has a lot of potential if you look at it from a widely used library that everybody uses. Let's say if there's a minor version update, would you update straight away? I would say no, wait for the window. So this blog post also has a timeline underneath. It will show you the most significant attacks that were made, and then showing the time window of it was found, the opportunity, something going wrong, and then when it was fixed. If you, as a consumer of a package, stay behind that timeline, you're good, right? If everybody does that, we have a problem because we don't have stuff serviced. But I think for high volume, publicly, widely used libraries, this can be helping you out right now if you do this. Of course, a security vulnerability update, that's a necessity to like get in and to do. But the more significant, bigger ones, then if everybody has an eye on it, and even all the security vendors, us included, we will look into newly published stuff, right? Will help you. So that will give you more, hopefully less work, right? I think that's the take. I like this take. I thought like I need to share this a bit because, as I said, I want to focus more on audits and knowing what's inside. And this is a picture, I've talked about scorecards, people probably have seen this in the past. So Club Mate is a drink you can take. It has a lot of caffeine if you need to stay awake. Hackerspaces have it. But if you look on the bottle, you will have a label of like nutrition facts that will explain to you like it contains 3 cubes of sugar, which in my case is probably not the best thing to take. But it will give you a well-informed like way of saying like, hey, this is something that's a good idea. A lot of salt, no. Might be tasteful, but I don't want to take it, right? It allows you to decide if you want to do this or not. And wouldn't it be nice if we can do the same with dependencies? And the answer is, of course, yes, because we have OpenSSF Scorecard, security scorecards. And the nice thing it's an automated system, and it will have a scoring varying from 0 to 10, based on different security types of practices. And the nice thing is you can apply it on your own project, but you can also question that same data of all the dependencies that you're pulling in. And it will have a score, right? And I think this is cool, and the community works on it. It can help. The checks itself will have different checks. I'm going to just briefly go through them after this. But I think that's a nice product. But it's ease of use, just a tool. There are different ways, and I'm going to show you. So what are the things that it looks into, right? Does the project have vulnerabilities, right? .NET CLI can help you out as well, but this will check it as well on the project level. Is it maintained? Is it actively maintained, or is it been like not touched in 3 years? That might be a red flag as well. Does it have a policy published? Does it explain people like, hey, if you find a security problem, reach out to this address or put your data here, or in the case of Microsoft, make sure you publish it throughout the right channels in order to be eligible for the bug bounty, that kind of thing. If it has a policy available, it will check it. So these are the checks that it can do based on GitHub-based repos and also on GitLab. So that's pretty nice. The other thing is it looks into maintenance. Is there any license defined, right? Legal stuff might force you like to have a license tree of what's used. Are you able to use the library in such a way in your production thing? CII best practices, that's how it looks into more like a check you can do, and it will be audited by somebody. Does it use a dependency tool? Do you have Dependabot installed on your pipeline, and does it work? Like, does it do pull requests to fix stuff? And the other thing is continuous testing, CI tests. If you develop stuff, hopefully everybody has tests in place that you can run that shows the functional things are still meeting expectations. For security testing, does it do any fuzzing or static analysis, right? That's the space that we're in, but is there any tools presence that will indicate this is happening? Then if you look at the risk assessment from source perspective, the really high one is the binary one, right? If there is a DLL executable inside the repo, and it's not correlated to any source, like, hey, that's a risk, we need to look into it. There are certain best practices on GitHub, which you can look into branch protection, get dangerous workflows. I believe the talk at the end of the day will talk about that as well. So I'm not going to touch it. And then more like a assessment-based code reviews, Is there any code reviews done implicitly? Like, is there 2 persons involved? Changes being made? Is it being reviewed by somebody else? The amount of contributors from different organizations. If there's a lot of contributors, that might be a problem as well. But I think research has shown out, and I've got another talk on that where I've got some figures on that, that it's definitely good to have more contributors, more eyes on the code. So that's a check that they do. And we have 2 more based on build risk assessment. Do you use, or do they use any bin dependencies, right? With the NPM stuff that we see right now, and it also propagates throughout the fact that it's used, and if you produce NPM packages, it might propagate itself to that package as well. You want to stay on a pinned version knowing that you're not using the vulnerable one. For .NET, there is the same. You can put out a version in your GitHub Actions, for example, but it's better to point out to the hash of that version you're using, because that, you know for sure that that's the one you're going to use instead of the version. There's a certain thing with token permissions that's GitHub related. You can check that one out. And the last thing is also important. Is it part of a packaging ecosystem? For us, for NuGet dependencies, if we want to update, we want it to be part of the NuGet ecosystem, right? To update it. And does it do any signed release? If it's signed, then it's good. That's of course not the answer, but it will at least give you the guarantee that a thing was produced at a certain point in time with somebody or with a process that had access to a key to sign it, right? So you can probably, hopefully, have more supply chain artifacts explaining to you like, hey, yes, this is good. But 9 out of 10 times, if it's signed, then there's probably a way of dealing with this. So I'm not sure if I'm going to run this one. I'm maybe going to move over to the labs, Fennec Labs I created for this. But if you do OpenSSF Scorecard, there's a CLI tool you can use yourself. And the other thing you can do, and it will run locally. It only needs to have a read access token to GitHub to do the checks for you. So it will do it at that moment in time using that current version of the scorecard. And it will produce a list. I'm not going to bother you with that, but it's just going to take time. But there's also different ways of getting the data, because luckily the data is also published. So let me show you. So if you go to this site, you can download it, right? That's a way of working it. But you can also request it based on a GitHub repo. And if you look into this one, this is the one from Azure SDK that I opened up this morning. And you can go throughout the checks and then see that it has a total score of 6.6. So there are different severity levels in these checks, and that will also have its effect on how it's calculated, right? So a high or critical severity will have more at the end result, and that will be scored 0 to 10, and then it will be added up to that figure you see on the top. And you can see like, hey, a branch protection, it scored a 5. It might give you an example like why it concluded this. So this is data. The only way you can do this right now is doing it on a GitHub repo URL. So NuGet package, you need to correlate where it comes from. That doesn't work, right? The NuGet CLI has the option of --NuGet, and you can put in a name and possibly also a version. I have to check that one, but a version and a name, and it will get that scorecard. Still, is it usable? I don't think so. What would be better if you just are able to go to your solution that you're developing right now and ask it to produce scorecards? So one of the things that hopefully you're able to see this. My screen is not like helping if I put this in. So I've installed the Fennec tool I created over here in on my machine. I will tell you at the end how you can get it. You can do a scorecard command, and it will do it based on the project itself. So if I say scorecard right now, it won't do anything because it's not in a project. So let me go to, there's a folder called web app. Let me show the contents of that one first, which is just an ordinary .NET 10 web app. It has a project file, and it has dependencies defined here. It relies on the SDK of AWS. It uses mono-CSL, and it has a dependency on Mach on specific versions, right? So if I then go to that folder and say Fennec Scorecard, what it will do a lot of things. Let me maximize this. Let me collapse this one. It will iterate over the projects. It will see. It will use the .NET CLI underneath. It will define all the dependencies, and then it will grab all the scorecard information. So what I'm using myself underneath the hood, it can also produce JSON files and save it. But for the sake of the demo, I also said, like, hey, let's also write this one out to the console. So this is information you can use to just like, hey, looking into certain areas. If you're worried about binary artifacts, if you're worried about certain checks of the scorecards, that might be something you can focus on. And you can take better informed decisions. A score of 2 is, of course, less than a score of 6 or 7, right? Define for yourself what you expect and how it works. Of course, this is not really usable if you would be a developer, right? The security person might be able to do it. So I thought, like, hey, can we not do something else with it? So there's a good vibe to this. I'm going to say it to you, right? So this is just something I vibed into this demo. But you can also, hopefully, just take a dashboard type of style and say, hey, produce a dashboard of the dependencies, right? And you can see on the coloring and what I've used here, this is just, it was a 2-shot thing, not a single-shot thing, but it will show you, like, hey, this might be a way of how it can work as well. And would it be nice if you have like a dashboard that you can just run inside your project that will produce this for you and store this information? I'm going to get to that in a bit as well, but this might be the way of dealing with this data, right? So you can see the average score for your project in total is this. Maybe you can say there's a threshold, but it doesn't, like, as I said, a score also needs to have more context. You need to be more aware of what it has checked and what's important to you. But this allows us to do that, right? To assess the projects that we ingest. So that's cool, and that helps us. And that is the first bit of Fennec that I showed. And as I said, it's work in progress. I put the line on top of it, which I think, like, hey, a lot of ideas, little time, and I want to do it, right? But keep in mind that this is at least metrics that I would love to see us being, like, using easily in a dashboard. And that's what the goal is. The other thing I talked about a bit earlier is, like, if you have a binary artifact inside the package, you want to know if it's reproducible, right? If there is an independent path from source to the output. And I also would love to see it's deterministic. It needs to produce exactly the same if you're doing that. Roslyn has got some deterministic designs done. I think it was a lot of years ago, I'm not sure like which year, but there is a document defined by the Roslyn team that says if you compile with Roslyn, a certain sequence of dependencies of SDKs will have effect on how the output is produced. But 9 out of 10 times it will be the same, and that's cool, right? So that will give us the confidence that if we create a project somewhere at one spot, and then if we rebuild it at the other spot, it will be exactly the same, and we can compare it. If you do I have one demo, I'm not going to show it, but if there's a demo script inside of the repo, if you do a console app, new console app, with a name, and you copy it to a second folder, and you build it, will those two be the same if you look at the DLL level, byte by byte? And I'm already going to spoil it. The answer is no, because there's always that PE header that has additional information. If we look into the IL of the binary, it's the same. It's that Hello World console app, if you look into it, right? That should be identical, but there's always that bit of the header that's different. And that makes it hard, because technically from reproducible builds, you want to have that guarantee that it's exactly the same. I think that's the key thing. So what can we do about this? We should be able to look into packages and see if we're able to reproduce and look at the IL and compare. That's exactly what I created for the second module of Fennec Labs. So let me show you a bit what I've done here. So I think it's in GitHub. So Serilog is a library that you can use to do logging, right? And it just plugs into ASP.NET Core as the logger. You can configure it, you can use it. So what I've done, this is the version I pulled. Let me see if I get status. I think this is status, it's up to date. I pulled this morning. This is the source repo. So let's say I'm able to build the package and I want to create the artifacts. So I already did this before this training, but if we then go to the artifacts folder, you can do like .NET publish, and it should be .NET pack. Hold on. This is the single file stuff. That's pretty cool. .NET pack. I think I should have. I'm a bit quirky right now. So if you then have this in, you can publish it, and then the artifacts folder of this repo contains the different packages. And this is the NuGet Serilog package that I would expect to get from NuGet if I do this. But if you compare the files at files level, you will see that they're different. But if I'm instrumenting it to look into the content, then we will see that that's going to happen. So With Fennec Reproduce, you can give a file name. In my case, that's the package I built according to how the build system has done it for Cellulog. And that's the biggest thing. That might be a hard one to automate, but if somebody can do this, right, I can sign off and say, this is reproducible. I've taken a package and I'm going to say, compare this to the version you find on NuGet. And then what the tool is doing here is it will grab the package from NuGet, and it uses your local NuGet cache. And then it will check the version I built and compare the IL of both of it. And it will look into the class level, the implementations, the method bodies. There's even a detailed version you can get that will show you exactly what the differences are. But this right now tells us these are identical. And if there is difference, it will produce more output. So this gives us a guarantee, right? I could now share, like, hey, with this project, hey, Niels, I'm Niels, I looked into this project, and yes, this is reproducible. I can sign off for this, right? And if more people do that, then we have a valuable, like, piece of information that everybody can decide if it's good or not. And if we do that on crucial packages, that might help, right? So reproducibility is key, because we need to know for sure that the package source that we find on the internet is also the one that's built with, right? So that's looking more into, we have source, we have binaries, and then there's the whole story about the IL weaving I talked about, so packages being manipulated afterwards. Or general having a better understanding of what's inside a package and what you need to do. So when I started out doing static research for Veracode, I wrote a tool that dumps all API calls of a .NET DLL, and it does it in a flat file. And I've been using it ever since. I'm going to show you in a bit like why I think it's valuable. So if you look at, let's say, malware, how would you identify malware? Let's say in a static analysis space, how would you identify malware? That's a hard problem, because it always is a case of a chain of things that happens. It's not, there's a process start, there's a download done from the internet, there's maybe some files being deleted. That makes up a piece of malware, but distinctively looking at the different pieces, it might not be true, right? And that makes it hard. So what I created is a thing that can produce the files from a package that's online. And this is definitely something for a security researcher that I'm using. I'm going to show you an example and see how it works. But this is definitely security related and helps me review, and I'm going to show you why. So let me reopen a new shell, and let's say I have instrument folder created for this one. It's empty. If you go to Fennec, you can also say instrument, and you can say, okay, go to NuGet, grab the version of Castle Core, which is a library that I put also in the web app you saw before, and instrument it for me. And then it's going to download the files, and it's going to produce the text files I talked about. And you will probably say, like, hey, Niels, this is a security like explosion of information. Yes, for me it makes sense, but I can show you what's inside, and then we can move on, and then how we can use that data. So let me collapse this, right? So .NET library can target different frameworks, so different frameworks have different implementations, different DLLs inside the package, so I'm going to create this for each of the different targets. But if I'm now collapsing this, what we see here is that there is an extender logger factory instance that has a method called getConfig file, and these are all the flat API calls that it's doing. So this method is a method body. I sorted it in such a way it will always be like an iterative list you can go through, and with selections it's nicely highlighted. So I can say, hey, what I see here is like system IO operations that are done, which are looking into a path and opening up a file, and then it combines stuff, and then it gets file info. This might be a hotspot that I want to look into, right? If you look at malware, this might be a characteristic saying like, hey, this ends up being malware at the end because certain things are in. I think that's the key. And I tried to do a report thing on this as well, just to show like I can vibe code, but that's going to explode in your face because it's so much information. I need to look into it, right? But there's definitely potential of doing stuff with this data. And one project, if people have been in my my presentation, other presentations before, is when I talked about in the past that might help us out. And I'm definitely looking into this kind of thing, because there is a project called Application Inspector, which I don't think has a lot of activity lately, but Microsoft security team has released this. And what this does, it does, based on a source repo, tell you what are the features of the library and what does it use. Does it start processes? Does it work with cloud storage? Does it use authentication or encryption? And these are all kind of features things, right? So if you correlate back to the data I showed you before, wouldn't it be nice if you could develop a dashboard that you can look into a library and see, hey, this library relies on these features. Does it make sense? Or this library, previous version had these features and the new one has these features. That might be an anomaly, right? And we need to look into that. Or you can decide to look into it. So the nice thing about Application Inspector, you can do it on a source repo, you can check it out, it's still usable. But it will also give you a confidence level, like these are the things that I rely on. And you could question, this is a library to do document generation. Does it need to do heavy crypto? Maybe signing of documents, yes. Does it need to go out to the internet on its own inside the library to do requests? That might be a request forgery issue in there, right, if you use it. That's the thing. So I think this is valuable if you see that previous information to have that dashboard. And the dashboard that will then, if it starts inside your project and you can instrument, that will be helpful information. So future things. Then one other piece that's also in that, which I'm going to probably skip a bit because of the sake of time, is the fact that we have the ability to compare instances. So there's also a compare command that you can point out to NuGet. And what it right now does, it will take the current version, grab the previous version, and then show you the differences. And it will show you like, hey, this method has more instructions and these instructions are added. So for me, it will allow me to quickly see if stuff might be bad or not. And it would be nice if you're able to also get some of those metrics included. And it relies on the same IL comparison, right, for the reproducibility, right? It's the same bits that we look into, only now we're taking two versions of NuGet and just compare them to each other and see if they're identical or not. So that might be valuable. It's always the argument, if .NET team produces a fix for something, I'm always curious, like, hey, what went wrong? Can we reproduce, like, what is the fix that they've done? And if you look in the .NET SDK or the frameworks itself, it's always a shattering of packages combined. And how can you then dissect easily what happened? When we were talking about the whole security information being put inside the .NET CLI, Barry Dorrance asked me, like, what do you like to see in this? I said, like, I would love to see an example, how it gets exploited. He says, like, no, you're not going to get it. That's the exact reason, right? Because we need to understand. I would love to understand stuff and see if I can apply it on different things as well, right? Compare allows us to see it, right? I think to compare previous versions, that will give us a better sense of what's inside. So that are the things. If you then look at a future idea, and I think looking at scorecards, there's a piece on fuzzing, and I would love to see also fuzzing included because it helps us out, right? Because it will provide invalid data to a component and then see how it responds, right? It will just slash it with a hammer and then see if I give it this input, this will happen. People will always think it's only good for unmanaged things like C++, but I can assure you that it has value for .NET as well. And this is a blog post done by the person who did Sharp Fuzz, and he even created some good reports on bug bounties for it. But he looked into, I think it's always AFL fuzz, and there's a different fuzz engine that he later on included that allows you to fuzz .NET libraries and look into the things that are inside and see if it behaves badly. He has a whole blog post, check it out. I think the biggest problem with fuzzing components, how would you fuzz a library if you have no proper idea of how to use it, right? And that's the same thing with looking at it from a static analysis perspective. If you look into a library and just assume everything is callable in your library, then you will produce a list of flaws because, hey, this variable is used over there to open a file, so that's a file traversal issue we see over here. But you don't want that noise because you want to have it seen as from how it will be used in your application. So the thing to solve would be to have more like a skeleton thing happening here, right? And this is what SharpFuzz can do. And I was really thinking like, hey, we can just maybe have this generated by some LLM to help us out. Like, hey, I want to have a test case that instruments this component. These are the inputs that I'm worried about. Generate this class for me and execute this, right? This is pretty cool. And Rust also has a project that has exactly that goal. They said, like, we need to have test benches, and they will have LLMs helping out creating test apps to fuzz targets, right? And this is also useful if you look at it from a static analysis perspective. If I know how a library gets used inside your application, that will give me higher quality results if I want to statically analyze it. I can always have that signature check done, saying like MD5 should not be used. That's probably the one you see a lot. And it's true, but it depends. But I'm mostly interested in data flow things, right? Something starts here and runs inside your app and then executes. And I think if we can have an automated way, looking at libraries in general, to fuzz and do SES, but also have tools helping us out, creating skeletons for it, that's a key thing. And I would love to see that in Fennec Labs as well. So getting back to what I think would be good. I would love to see, every project needs a local dashboard or a dashboard, right? And that's the thing that lacks right now. And I would love to have one that helps out if you're developing stuff and only interested in high overview, saying, is this a big risk or not? And you can work your way down from that. I would also love to have like a centralized version, maybe with APIs, that everybody can consume data from, right? So let's say if there's a group of people that really did a really thorough review of Castle that I just showed, and they're going to share it and have that information shared with everybody, including like, hey, these are the scorecards. I've reviewed it, it's reproducible. If we can share that data with everybody, that will benefit, right? That will help as well. What about having it exposed as an MCP to an LLM? Maybe even create some template prompts to help out reviewing, right? That might even be able to turn that developer into that security reviewer, right? If I put in a prompt that helps out people, like, hey, this is the thing you need to look into. These are the risky functions you're interested in seeing. Does it do any process stuff? Like, if we can instrument it in a better way and having the tools available, then we can probably make some good automation, right? And make it happen. And even if you then are able to sign it off, like, I would say, like, hey, I could go to Sigstore, sign a document and say, this is Niels, and I've signed this. You can trust this. This is information I shared. There's a lot of potential in that. And one demo that I also created on my machine, and I'm not going to show it, but taking a Roslyn analyzer. Let's say I've reviewed a package and I've identified, you saw that file open being done inside that Castle library. I can tie that to that API call within Castle and flag that API call within a Roslyn analyzer and putting squigglies underneath it and say, like, hey, be aware that the data that comes in here will eventually be used to open a file on your system. So make sure it's properly, is it properly vetted, if it's normalized before you put it in, right? It's all about input validation, right? If you talk about the security person, say, like, what is the one thing that people need to do? Check your data and see if it meets your expectations. And that's the thing. So I think in that perspective, a Roslyn analyzer with centralized data that can be fetched, right? That might be helpful as well, because that will put it inside the hands of me developing. Hey, and if somebody else shared a library and it should not be used in a certain way, I would love to know that, right? So there's potential for doing that as a future idea for Fennec. So we're close on getting the 15-minute mark, so that's good. As I said, doing software security in general is hard because software security professionals do not scale, right? And it would be nice, like, I still love to develop, and it would be nice if we can turn around and share information. And I think that will be the benefit. You also see companies like GitHub, right, giving you money to help out open source and fixing it, right? There's even bug bounties that are given by bigger corps to make sure that that library is safe because everybody relies on it. I think that's valuable. The package ecosystem has been Wild West, right? If you look at NPM, but even the example I showed you before, the socket blog post, NuGet, is definitely not free of this. And it's beyond trust, right? We need to make sure we trust, but we also verify. I think that's the key thing I want to take away. And I would love to see data shared, right? And allow everybody to have the ability to take better informed decisions without having the security fatigue of, like, hey, there's like 10 problems here, yeah, but maybe 9 or 8 are not applicable, right? It needs to be actionable. That's always the take on it. So there's the balance act. So with that said, I'm gonna wrap up. If you want to see the demo, the slides, so all the slides I have links to the origin of the article that I pushed, that I showed you. You can find it on that NDC Manchester repo, and there's a Fennec Labs folder that has a NuGet package. And if you go to the README, you will see that there's a .NET tool command you can run to install that package locally. It needs to go to NuGet. I'm a bit like, when is it done? And I always get the question, people say, like, just publish it, Niels, just don't complain. But there's some supply chain stuff I need to fix before I'm doing that, and to make sure that I'm in the right spot, because you need to practice what you preach, right? But there's a couple of events in the future I have, which probably at some point I will have it published, so keep an eye on my socials on seeing it there. And with that said, I'm going to open up for questions if there are any, and otherwise, yes? I'm not sure if there's a microphone, otherwise I will repeat the question.
So thank you, great talk. I was wondering, so those supply chain attacks, you try to do a lot of prevention, so you know that you get into your system. The supply chain attack is typical targeting one shot a lot. So on the other side, if you have a very big system, you can imagine that sometimes you get hit.
Yeah,
it's just a fact.
Yeah.
So I think also where we have to think about how to protect our systems better.
Yeah.
That the hit is not so bad. So those libraries have access to everything. Why? Is that needed? Can we not drop capabilities, for example?
Yeah.
Things like that. Can you give a view on that?
I'm not sure if I get the question fully. So
what I say is that I think we should also be better prepared than we get.
yeah, it happens, right? I think it's naive to think that nothing's going to happen at all. And as I said, I would love to have information available that I can make up, say like, hey, I can share it with everybody, like, hey, this latest version of this package, there's a problem. If I only look at like NuGet itself, right? Don't get me wrong, supply chain I've done talks about this, there's a lot more complexity in the whole chain. Source, binaries, everything that's underneath, all the stuff that's involved, right? You should just assume at some point it needs to be, it's the same with security in general. If we look at security development lifecycle, there's still a need to doing all best practices, doing your threat modeling. If you're pulling in an LLM, you should question yourself as well, like, hey, is this really needed? But like that kind of thing, those are all risk-based choices you make. And at some point it will happen and we need to act on it. And I'd rather have the information, that's my goal, right? To make well-informed decisions. So I agree with you. If you say like, hey, it's gonna happen, we need to anticipate, yes. And also learn from it, right? I think that's the key thing, seeing the stuff that happens to the different ecosystems and make sure that the ecosystem will take care of it in a way that it will be reduced. But it's naive to think it's not gonna go away, right? Okay, any other question? If not, I'm gonna say thank you. Enjoy the rest of the conference, and I'm around the next 2 days, so thank you.